and welcome back to Teaching Statistical Thinking. Unfortunately, this is our last video of the part 1 of the course, so let's get to it. Today, we're going to look at comparing two numeric variables using something called regression. So, if we take a look back at our Forbes 100 data set, what we're going to do is go to Analyze, Fit Y by X, and find two numeric variables. So these are the ones with the purple triangle. So we're going to use marketability rank of the celebrity in the Y and earnings in millions. So what this is going to tell us is as earnings in millions increases, what happens to the marketability rank? What is the correlation between earnings in millions and marketability? Alright, so we're going to click OK, and we have our scatter plot here. So we're going to click this red triangle right here and say fit line, and that's going to give us all this information right here. We can go ahead and click these gray upside down triangles to close all this information. We aren't going to need it right now. That's for later with inferential statistics. And then we can go back up here, and we're going to use something called a density ellipse. And so we're going to go 95 density ellipse. So that has about 95% of the data within that density ellipse. And you'll notice if you look at the bottom of your screen, it also gives us the correlation. So if you click that triangle, it'll give us the correlation right here. So if we take a look, the correlation between earnings in millions and marketability is about 0.35. 0.35 is a positive correlation. So that does mean that as earnings in millions increases, so does marketability rank. But if you take a quick note at marketability rank, it goes from 0 to 100, 1 being the highest and 100 being the lowest. So if you take a look, as earnings in millions increases, so does marketability rank. But as you increase marketability rank, that is not necessarily a good thing. The higher marketability ranks are the lower numbers, and the lower marketability ranks are the higher numbers. So actually, even though this is a positive correlation, what that actually tells us is that as celebrities earn more money, although they increase in marketability rank and have a higher marketability rank, they have a worse marketability rank, meaning their marketability is not as good as celebrities with lower numbers and lower income. So that's a tiny bit confusing. I'll try and hash that out one more time. So it's a positive correlation, which means that as earnings in millions increase from 0 to 140, marketability rank increases from 0 to 100. But that's not necessarily what you think it means. The numbers, the low numbers, let's say from 0 to 40, that is a very good thing. They are very marketable to the public. Celebrities with a high marketability rank are less marketable to the public. So that's a tiny bit confusing, but celebrities with a higher income are less marketable to the public, and celebrities with a lower income are more marketable to the public. That's what the correlation shows. So let's say we had a correlation of 1. What does that mean? Because our correlation can go from -1 to +1, 0 to -1 being a negative correlation and 0 to 1 being a positive correlation. So let's say we had a correlation of 1. So what that would mean is that all of the points fall on the same line. Correlation of 0 would be that there was an equal distribution of points along 20, 40, 60, 80. So at earnings in millions, there was the same distribution of points as at 40, at 60, at 80, so there would be no correlation between earnings in millions and marketability rank if the distributions of points were similar in 20, 40, 60, and 80. Alright, so we can go ahead and take a look at our line of best fit and look at exactly what it means. So this line is the equation for this red line right here. So the marketability rank, which is our Y variable, equals about 31 plus 0.4 times whatever our X value is. And so we can plug in any X value here, and we plug it into earnings in millions, we multiply it by 0.4 and add about 40, and that's going to give us our marketability rank on this red line, which is the line of best fit. So that about does it for our overview, our simple overview of regression and correlation and the line of best fit. So one quick note with regression and correlation. This is a key thing to keep in your head. Correlation does not equal causation. Let me repeat that again because it's very important. Correlation does not equal causation. So, as we said, as earnings in millions increases, the marketability rank gets worse to the public, you're less marketable to the public. We can't say the people who make, that because you make more money, you're less marketable to the public, and because you make less, and if you make less money, you're more marketable to the public. That is not at all what this shows. This just shows simple correlation between two observations. It does not tell us causation, that because this happens, this happens. This is just a correlation between two observational numeric variables. All right, so that wraps up part 1 of teaching statistical thinking. I hope you had a wonderful time, and I hope you learned a little bit about descriptive statistics. We hope you join us for parts 2 and 3 with inferential statistics and probability. Hope you enjoyed, and happy statistical thinking.